Hello, hi. So today I'm going to do this problem called construct a binary search tree from preorder traversal. What essentially says is that we get a preorder traversal array, and we want to reconstruct the binary search tree. And the preorder list is just preorder traversal is just traversing first the root, and then its left child, and then its second child, right child. And so we'd have 8. And then we traverse the left child, so 5, and then we recurse on that, so 8, and then left child 5, and then 10, and then left child of 5 1, and then right child 7, and then left child of 10 nothing, and then right child of 10 12. So that's the idea. So what I'm going to do is do it recursively, and for each set of the array pass the limit. So what I will do here is that I think, so I'm thinking I can do, so create a node with 8, and then go to I plus 1, and say to the left side that the limit is 8, right? It should not exceed 8. And so this would go to the left child, but the left child limit is 5. And so we set the left child, and the right child limit is not 5, because the right child should be bigger than its parent, but it shouldn't be bigger than the parent, because the parent of 5, because all the left child subtree should be smaller than 8. And so this here should be with a limit of 8. And so basically what this would mean is that for left side, limit is node val, right? So for node dot left, and for node dot right side, limit is the same limit as the parent, right? So what this would mean is that my helper function will need to have I and limit. Okay. So I wanted to define it, and then here this will need to get limit, and then if I is bigger or equal to the length of the preorder, or if the value, which means preorder at I, is bigger than limit, then we shouldn't continue on that side, so we should return none. Now we should create a node with the value preorder I. Now the left child should be a helper on I plus 1 with limit. So the node dot left, the limit should be the node value. And node dot right, it should be helper I plus 1 and same limit as the parent, and we should return node. And then here to call it, I'm going to do helper 0, and the limits, at the start it's just the infinity, because it can be, we shouldn't limit the root, and so we can return that. Let's try it. Okay, this is definitely wrong. It seems like we didn't increment I in some cases. Okay, I think it's because here we do I plus 1, but we don't take that into account with node dot right. So I think what we can do is override I here, override I here, then I and node. And here I will need to return just 1. Yeah, I don't like this, but let's just do something like, maybe we should instead make I be a property of the class. Oh, sorry, I didn't do equal. Okay, yeah. I'll just do I for here instead of passing it. And now can do return. You don't need to pass I here. You can just use this. Okay, let's try this. We don't need to return anything like that. Okay, looks like that passes test cases. Let's try to run it again. Okay, that does get accepted. Okay, so that passes. Yeah, I think, yeah, so yeah, this is a good idea to pass the limit here. And just traverse the array until we reach the limit assigned to the whichever side we want, and then go to the next side. Yeah, I think that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.